Yeah. Yeah, there's all kinds of stuff that we could learn today.
Yep.
Yeah. Mm-hmm. Yep. Like I always want to know why did evolution stop at stereo vision? Why didn't it go on to digital or CD vision?
HD.
How come we don't have Dolby Vision?
How come I can't see in 3D? Why do I need glasses to see in 3D?
These might be questions people are wanting to know.
I think they are. And I think it's our duty as journalists to
We're journalists.
to ask the hard questions.
Man, becoming a journalist is easy.
Who needs education?
That's right. We need some microphones. We're journalists.
This is the AT Banter Podcast, a balanced and entertaining look at assistive technology, accessibility, and its importance in people's lives. Join Rob Minot, Ryan Fleury, and Steve Barclay as they banter with people around the world about anything and everything regarding assistive technology and the disability community. Now, on with the show.
Hey, and welcome to another episode of AT Banter.
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 My name is Rob Minot, and joining me today, as usual, Mr. Ryan Fleury.
Good day.
And Mr. Steve Barclay is here.
Howdy.
And we're journalists.
Yes, we are. We've decided we're
That's
journalists. We're going to ask the hard questions today in this podcast.
That's right.
Yeah, who knew that all it took to become a journalist was setting up some mics in a basement?
And having questions to ask.
Yeah, I think all it takes to be a journalist these days is an internet connection.
Yeah,
Well, that too.
It's true.
Anybody can generate news as long as they have a Facebook account
Yep.
and some 65-year-olds to read your post.
And then share them.
Yep. Geez, where to start? I really do feel like we're still out of practice of this a little bit. I think the Christmas break kind of hurt us.
Still out of practice?
Yeah, I mean, honestly, I feel like it's going to take a few episodes under our belts to really get a feel for this again and how this all works.
Well, we haven't really had a couple weeks in a row flowing yet either, right? It's been kind of broken up and sporadic. So once we get back to a regular recording schedule, it should be all right.
Yeah.
So you think we'll get better at this?
No, I didn't say that.
Well, it's like a crazy.
Yeah, because I was going to say that sounds really optimistic. It's just bit of a stretch.
It is. How's your week been, Ryan?
My week has been fine and dandy.
How's your week been, Steve?
Mine's been dandy, but not fine.
Rob, how about your week?
Oh, thanks for asking, Ryan. My week has been splendid.
Splendid.
Nobody cares.
Yeah, I know. I know. This is all getting cut out.
No.
It's going nowhere. Hey, Ryan.
Yes, Rob.
I heard a rumor that we have a pretty good show today.
I've heard that same rumor.
Yeah, since you started it. What are we doing today?
Today we are talking with Dr. Chad Andrews, who is the Manager of Research and Education at the Foundation Fighting Blindness.
And
Cool.
Steve, what is the Foundation Fighting Blindness?
Well, Foundation Fighting Blindness is a nonprofit that basically does what it says on the tin. They fight blindness. They step in the ring with blindness all the time, and they just punch it right in the head.
No, they're doing some very important work, of course. They are based in, where are they based?
Toronto, I believe.
Okay.
Yeah.
And been around for years, and they do a lot in the realm of vision research. So we invited Chad to come on and talk a little bit about how they've been doing the last few years and what progress has been made.
There has been some really incredible research that's happened over the last few years, and there's all kinds of exciting developments. I was at a Foundation Fighting Blindness show in Victoria a little while ago, and the exhibit area that I was in for the first time was actually in the area where they were doing the presentation. like every other show that I've done with these guys, I've been outside of the presentation area.
Right.
And this was the first time I actually got to hear about a lot of the stuff that's going on and the studies and trials and things that people can connect with through the foundation. So there's some amazing stuff with some crazy results happening right now, right down to the point where there's like a genetic cure for one specific type of blindness. It's like,
Really?
yeah. They basically correct the gene and off you go. There you go. Your
Wow.
vision loss is cured.
Wow.
Yeah. So, and we're gonna be hearing more and more about this kind of research down the road, and people will be able to participate in more of these programs and studies. Yeah. So they look at the different studies, and they rate them and determine, are they properly set up? Are they safe?
Is there something to it?
Is there something to it? Yeah.
Huh. Interesting. And they're a nonprofit, correct?
Yes.
Yeah. Which is stupid to me. I don't get that. Like, why are they a nonprofit? Why aren't we funding these organizations that are doing such important work?
Well, there's grants and bursaries and stuff available through the government for research purposes.
No, still, we should be throwing some serious money at. Like, let's take
I was
that
going somewhere with
that
that.
$5 billion wall money and let's throw it at Foundation Fighting Blindness. How about that?
That wall's American. And besides, that's not our money. That's
I know.
I believe that's Mexico that's paying for that.
That's right.
But no, I never said Mexico would pay for the wall.
Well, nobody said Mexico would pay for the Foundation Fighting Blindness either.
Listen, if I had $5 billion, I actually would give him the money for a wall, and then it's my wall. I can use whatever I want. I'd sell advertising on it, and it would just fill. That's a lot of mileage of advertising space. Hello, you could probably make that $5 billion back pretty quick.
That's a lot of billboards.
Yeah, exactly.
What is it, 1,900 miles or something?
Yeah. Well, Jose, we made it to America. We made it to the Great Wall. But now I could really use some Doritos. This billboard's making me hungry.
That's like the worst Mexican accent I've ever heard.
Thank you. Listen, I'm a journalist, not a comedian.
I'm looking forward to talking to Chad about the research being done and, the different eye conditions that are actually being focused in on. There's so many different varieties of eye conditions out there. How do you pick and choose which ones are, prioritized? And to me, it's just going to be interesting to hear what's going on.
Hey, but before we bring Chad on, let's talk some news.
Ooh, what kind of news can we talk about?
Well, here's one thing that we can talk about. Let's talk about something stupid first.
Oh, that's
Because
not unlike
that's
us
really
at all.
our specialty.
Stupid?
Have you guys heard about this Bird Box movie?
The Bird Box movie.
Yeah, so have you seen this movie?
Yes, I have seen this
Yeah, it
movie.
wasn't a very good movie, was it?
It was okay. It was very suspenseful.
Middling at best.
Very suspenseful, but yeah.
Can you give it a rundown to explain it to somebody who maybe has not seen it? It's a Netflix movie.
Yeah, it's a Netflix movie. It's basically kind of a monster movie. The premise is that there's some sort of evil force running around, and if you see it, you go crazy, you go kill crazy, and you try and kill everybody around you. Yeah, basically anybody who wants to stay alive, if they go outside, they got to be blindfolded.
That's right, so they don't see the monster, so they don't kill themselves.
Yeah. So we have the lovely and talented Sandra Bullock starring in this.
Debatable.
And, well, which?
Part of that debatable.
Lovely or talented?
I don't know. I'm not a big Sandra Bullock fan, to be
Really?
honest. Yeah. All right, but she's lovely.
I'll have to see if it's described and maybe watch it this weekend.
Yeah.
Yeah, I'd give it a shot. I don't know. Honestly, it's not a great movie. It's okay at best. Anyways, we won't get into that because we're not a movie review show, obviously. But
Right, but
We are now.
The,
We are movie reviewers and journalists.
our resumes are just growing today.
That's right.
The reason why we're talking about this, though, however, is that as part of their viral sort of marketing or just word of mouth spread about this movie, and it sort of caught on, and on social media, and this idea of what people were calling the Bird Box Challenge sort of came up, which was essentially able-bodied people putting on blindfolds and running around trying to do things for up to 24 hours blindfolded.
Can I ask a question, though?
Go.
Why is it called Bird Box?
Because birds go crazy around the creature.
Oh, okay.
So they're carrying like a box of birds to sort of make sure that the monster isn't in the area.
Oh, okay.
So it's like the canary in a coal mine
Right,
kind of
okay.
idea. So yes, so people are out there blindfolded, running around and uploading these videos to YouTubes, and there's YouTubes. God, sound like I'm 75.
You're on those YouTubes.
Oh, God,
Granny, where did I put my YouTubes?
that's right.
You seen my
Get
YouTubes?
the Google machine out. I want to watch the YouTubes. No, so people have been uploading these videos to YouTube and, running into walls and running around. And of course, this has gotten the attention of the visually impaired community, of course, because, this type of practice has actually been looked down upon by the community for quite a while now. There was probably a time when the idea of blindfolding people and having a bit of a blindness simulator was sort of popular. But certainly in the past, what would you say, 15, 20 years, that it's definitely grown out of favor, correct? Because
Well, I think there's people on both sides of it still. Like, you can still buy vision simulators, and there's certain organizations that still use vision simulators. But, it leaves a bad taste in a lot of people's mouths because they feel that it's not really a true representation of what they're experiencing, and for somebody to just slap on a blindfold and start walking around is pretty dangerous because obviously they got no orientation mobility skills like a trained blind person would have. So it's just really a bad idea. Now, on the fortunate side, there's the chance that some of these people will be killed and removed from the gene pool. But, that's not a guarantee.
The same people that did the Tide Pod Challenge.
Yes, exactly. And the cinnamon snorting one. Or,
yeah,
Hot sauce. Or hot
no, that was
peppers
cinnamon eating, wasn't it?
yeah, they ate cinnamon. Yeah, all really bad ideas. But yeah, so it has caught the attention of sort of the community in general, and it's brought forward this conversation again where and rightfully so. If I was in the blindness community and watching able-bodied people slapping on blindfolds and running into walls, and
I'd be laughing my ass off.
Well, that's fair.
true, but after that I'd be annoyed because it's just a bad idea, and it it reinforces this idea that people living with blindness on a daily basis
Walk into walls. Can't manage. Yeah.
It actually which is a shame because when media like this comes out and brings something like the idea of blindness into the conversation, into the general social conversation, it's just a shame that it's done in a negative way that doesn't actually benefit the community at all. So in that sort of way, it's a little bit frustrating. But in the upside of this is that in 2 weeks, no one's going to remember Bird Box and no one's going to remember the Bird Box Challenge. These things are quite likely. These things are very fleeting, but we just thought it was interesting.
But it got enough hype that Netflix actually came out and made a statement. They tweeted out, "Can't believe I have to say this, but please do not hurt yourselves with this Bird Box Challenge. We don't know how this started, and we appreciate the love, but boy and girl have just one wish for 2019, and it is that you not end up in the hospital due to memes."
Yeah, and when Netflix is the voice of reason, you're in trouble.
Well, I don't know. They seem pretty reasonable.
They just upped their prices.
No, it's coming in February.
Dicks.
Exactly. What else? Hey, should we talk a little bit about CES, guys? CES was last week in Las Vegas. It's the big consumer electronics show. A few things I thought of note that we could talk a little bit about.
Screen tech. When you get in your 8K TV.
No. When are you getting your intelligent toilet?
Ooh, do you think I can say, "Okay, Google, wipe my bum?
On the website howtouttheorbit.com, they say, start out with a decent size wad of tissue. 3 balled up squares should be plenty. Reach around and behind your butt and lean onto the opposing cheek. Wipe with the pointer, middle, and ring fingers of your active hand under the
Oh my.
To read more, look for the link in your Google Home App.
See, Google knows all.
Wow, that's
Okay, now watch this. Alexa, how do I wipe my bum? See,
Alexa doesn't know.
Not even on the
Google-
same playing field.
Yeah, Google has all the information. Google will walk you through it if you somehow made it.
Step by step.
yeah. I wonder if you could ask it for step-by-step directions. Or, hang on, wait, I haven't finished pooing.
Oh,
you
Lord.
can with recipes. You can give you the step by steps in sequence. So maybe.
This show just turned scatological.
Oh God, yeah.
Talking
okay.
about CES, now here we are getting poop and
right into the abyss. No,
No,
anyways,
right into the toilet.
right. Yeah.
Yeah, so Google had a huge presence at CES this year. What kind of stuff did they come out with?
Well, both Google and Amazon really they don't really say much at these shows in terms of a lot of announcements about themselves in particular. It was all about what.
Assistants are built into now.
Yes, exactly. So there's really an arms race going on right now between Google and Amazon in terms of how many different products can they stuff the assistants into, and that was basically that's essentially what was at CES. So there was everything from, like we talked about, a toilet that has Google Assistant built into it. What else? Smart plugs.
There's smart plugs. Amazon's got a microwave with the A word built into it. There's wall clocks. There's alarm clocks, like bedside clocks. Anything you can think of is now coming with the assistants built in. Your TVs, sound bars, speakers.
Cray.
Mm-hmm. Well, the nice thing is that a lot of these companies are including both assistants in it. And for me, who has both, Google Assistant and the Amazon Assistants, I don't really want to have to choose one ecosystem or another. I'd like to be able to use both because, there are benefits to having both.
Right.
Well, and from a manufacturing perspective, are you going to put in just one and limit your audience
Right.
to half the world? Or are you going to go for all of it?
Right.
Yes. Yeah, so it's going to kind of be interesting to where this all lands in terms of going forward. I don't think in anyone's world one device is going to win out over the other and the other one will disappear. I think we're going to have competing ecosystems for the foreseeable future. There's going to be Amazon and there's going to be Google.
You don't think one will eventually become the Betamax of voice assistants?
I don't think so. I don't see it. I mean, I think they're both. Google is catching up to Amazon in leaps and bounds in terms of how many devices have the Google Assistant built in.
Yeah, there's really, I've got smart plugs and stuff in the house here. And, when I'm looking for a new product, there's really not a lot that I've come across that don't work with both already. So we're just going to keep seeing more and more of that. I think that both companies are well invested in this technology, and it's not going anywhere anytime soon.
So, and I think the real AT potential here, and the reason why we are often talking about the digital assistants is because it's taking those steps towards a smart home that is going to make life for a lot of people who rely on AT a lot easier.
I think it already has. The home automation stuff that we had in the past was pretty similar to the home automation stuff that's out now. The difference is that it's mass produced and cheaper,
Remarkably cheaper.
All readily done through a voice interface. If you're nonverbal or something, it makes it a little more dodgy. You're still going to need some sort of other input method, but
and that brings up an interesting point. I was thinking about this the other day about people who are nonverbal, and I'm just wondering if it hasn't already been produced, if there's something planned that is going to act as some sort of a liaison between digital assistants and, say, a communication device?
Well, I mean, if I was a communication device manufacturer, I would want to build that in.
Right. Yeah.
Okay, but a lot of
I wonder
these
if that's coming.
communication devices now, I think, are running mainstream OSs, right? Like Android.
Yep.
So, the Google Home or the Amazon Alexa have apps for Android or iOS. Mm-hmm. So could you not already use switch access or, scanning to go into the app, trigger the lights on or off or whatever your automation is that way?
That's a really good question.
Yeah, you may be able to. I've never actually tried with either of the interfaces to see if they're switch accessible, but
I wonder if that's worth a show. Maybe we could talk to somebody about that.
Yeah, that's not a bad question.
Because I do often think about that in terms of, like, I mean, digital assistants and voice activated products around the home are absolutely amazing for a lot of people, but for people who specifically are nonverbal, they're kind of being left out in the cold. And I just wonder if there are options out there for them.
Well, I mean, there's tons of options, both in terms of apps that have vocal output as well as, dedicated devices that have vocal output. And I would assume that vocal output would be enough to trigger
it. Yeah.
Probably.
Yeah, I would assume so. So, and you can just, for something like a communication aid, you can just have an OK Google button.
Yeah. It's okay, Google, go back to sleep.
Sorry, I don't know how to help with that yet.
Yet.
See, I love how optimistic Google is, right? Alexa just says, I don't know. The Google Assistant is like, I don't know that yet. I don't control your life completely yet.
I think there's probably a list that goes on when you ask a question like that.
Yeah.
And it goes on to Google's list, and there's some guy sitting there in Google going, "That's a stupid question.
Yeah.
That's also a stupid question. I'd like to know the answer to that one."
Yeah, and depending on how many requests, that pops up as, will determine the priority. That's one of the things that really bugs me about these assistants is a lot of these things like the language translation. There was another question I thought of the other day and asked Google and says, I'm not available in your area yet. Like everything lands in the US first. If you're going to launch something, launch it.
Oh, Ryan, you're such a
No, like why does it have to be US only? Launch it North America.
I don't know. Licensing. Okay, anything else to say about CES? Anything that stood out to you, Ryan?
Nothing that really stood out to me.
I mean, honestly, AT-wise, there was a ton of neat stuff. In terms of AT specifically, we've kind of touched on the digital assistant stuff. The only other thing that I thought was interesting was an announcement about the new models of the HTC Vive, which is a virtual reality headset. I thought was interesting that they've built in eye tracking into that device. In order to cut down on the amount of motion sickness that some people have been getting.
Right.
And I thought that was interesting because eye tracking technology in particular has been a big AT staple for a long time. And I thought that could very well make the Vive a viable platform for something eye tracking down the road. I mean, that's pretty powerful stuff to have built into a set of VR goggles, even for something like, say, the Iris Vision. If there was eye tracking in that device, that could,
potentially you could use something that had eye tracking as a means of mapping out somebody's usable vision, and then presenting information to the areas where they have usable vision.
Because that bubble vision that Iris Vision has, right? It magnifies certain areas of the field of view.
Right.
If there was eye tracking built into that, where that was all being done automatically, so wherever your eye was going, that's where your bubble was. That could really be a powerful piece of AT.
Potentially, yeah.
Yeah. So that's interesting. So
it also might have some real possibilities for the physically impaired community as well, because that's where eye tracking has been used most, as a means of input on computers or on communication aids. So potentially you could have, an on-screen keyboard presented and somebody would be able to type just by looking at the keys.
Right.
And you'd think in a headset-sized device like that it would be probably a lot more accurate because you're dealing with a limited field, and your tracking technology is really close to where the eye actually is.
Right. Yeah, exactly. Yeah. So that's something to keep an eye on as well. So hopefully maybe...
You made eye joke.
It's kind of topical.
My career as a comedian has begun.
Oh, no, we're adding comedian to journalist.
Yeah,
and
that's right. Triple threat.
What was the other one? Journalist.
Wait, now I forget.
Yeah,
my resume is just too packed. I can't even keep track of what I am now. Hey, Steve, why don't you tell the fine folks about Canadian Assistive Technology?
Well, Canadian Assistive Technology is a Canadian-based distributor of, guess what? Assistive technology.
I would not have guessed that.
Really? Oh, I got to work something better into the name then. And we do all kinds of low vision and blindness aids, as well as all kinds of physical access aids and accessible furniture. You name it. Visit our website at www.canastech.com.
Rick, let me ask you about this. Chaos Technical Services.
Chaos Technical Services.
Don't sound so excited about it. Woo! Speaking of repairs,
We are the sister company to Canastech. We do the repairs on low vision devices, reading machines, for libraries, braille printers, and pretty well anything in between. We can be found at www.chaostechnicalservices.com.
All right, joining us now is Chad Andrews, Manager of Research and Education from the Foundation Fighting Blindness. Chad,
Hello.
are you there?
Yeah, I'm here.
Hey,
okay, great.
Thank you for waiting for us. We were just getting stuff together. So, thank you so much for joining us. My name is Ryan, and in the room with me today, I have Steve Barclay.
Howdy doody.
And I have Rob Minot.
Hello.
Nice to meet you all.
So we're going to gang up on you with a bunch of eye questions.
Okay, that's intimidating.
Why don't we start things out in telling us a little bit about the Foundation Fighting Blindness itself and what type of research you guys do there?
Yeah, so that's a good place to start. We're a nonprofit organization, obviously. We've been around since 1974, and the organization's mission is to advance retinal disease research, education, and public awareness. So a big part of what we do, and I'll get into how the organization has evolved over the last few decades a bit, but a big part of what we continue to do and have always done is raise money to fund research into retinal diseases. And that includes research into gene therapy, stem cells, approaches in pharmaceuticals, as well as artificial vision.
Where do you get your money from? Is it all private donations?
Yeah, a significant majority of it is private donations. So it's coming from mostly individuals and families who are affected by vision loss. And in the 1970s, that's actually how the organization started. It was primarily families who are affected by retinitis pigmentosa, which is a rare disease that leads to a progressive form of vision loss. And these families kind of looked at the scientific landscape and the treatment landscape and decided that more needed to be done to develop very generally the science of the retina, and a little bit more specifically treatments that would lead to tangible results for patients affected by the disease. So it all really started with retinitis pigmentosa, and then slowly over the years, and as the science has advanced, and as we started to learn more about the human eye and about how these inherited forms of blindness develop and evolve, we've expanded our disease focus to include not only inherited retinal diseases like Stargardt disease and Leber congenital amaurosis and a number of others, but also diseases that are traditionally considered inherited diseases, such as age-related macular degeneration. We started to focus on AMD about 10 years ago. And a bit more recently, we've been taking a very close look at glaucoma and diabetic retinopathy. So what started as a pretty small focus, retinitis pigmentosa, that's roughly 1 in 3,500 Canadians who are affected by that disease, has grown to really include the vast majority of forms of vision loss, or a significant majority of forms of vision loss. And today in 2019, rather than talking about rare forms of retinal diseases, we're really thinking about the almost 6 million Canadians who are currently living with either vision loss or a disease that puts them at risk of vision loss.
And those numbers are only going up too. The number of people who are entering into that age range where macular degeneration is a real risk is only getting larger and larger.
Yeah, you're absolutely right. It's a great point to bring up. There are a number of different ways of projecting how vision loss is going to accelerate for the Canadian population over the next 5, 10, 20 years. But some forecasts suggest that number is going to double over the next 10 years. And of course, that's tied, as you suggest, to Canada's aging population, right, and the fact that AMD is so pervasive. It affects so many Canadians over the age of 55 years old. And really, I mean, the sort of basic reality that's tied to is the biology of the human eye, and the fact that it isn't really designed to last for 100 years. So we'll all experience vision loss if we live long enough.
'Tis true. I'm dealing with it now.
Are you?
51 years old. I had to get glasses. Terrible.
Well, we're really interested in funding treatments that will have an impact for Canadians who are living with retinitis pigmentosa, glaucoma, AMD, et cetera, et cetera. But there's a lot happening in the world of treatments for myopia as well. Some really incredible stuff. We're not involved in those initiatives, but it's entirely possible in this utopian future where we're able to genetically engineer cells that will have an impact on how our eyes function. It's entirely possible down the road that even something as simple as eyeglasses won't be necessary.
Oh, never even considered that possibility.
I mean, you're 51, so you've still got a shot.
Yeah, that's right.
Beautiful. So let's talk about some of the research that's going on, because there is so much happening right now, and some of it is showing some real promise. I heard a colleague of yours speaking in Victoria a few weeks back, and I was just stunned at some of the things that she was talking about. So why don't we start with the state of research for RP right now, and some of the more exciting stuff that's happening in that area, because that's kind of where you guys started out.
Yeah, definitely. Well, you mentioned gene therapy at the outset, and I think that's actually a really great place to start. And, it's the start of 2019 right now, so I'm kind of naturally thinking about last year and kind of reflecting on all of the exciting developments that occurred in 2018. And you can't really talk about vision research in 2018 without addressing the elephant in the room. And that is really something that occurred at the end of 2017, which was the FDA's approval of its first ocular gene therapy. So it's a treatment called Luxturna, and it's now available in the American market. So it's a treatment that you can actually pay for. And the patient group for this drug is a very small one. So I mentioned before that individuals living with RP, it's 1 in 3,500 in Canada, and in fact in North America as well. Individuals who are in a position to take Luxturna and have it improve their eyesight have to be living with a very specific genetic mutation. It's a mutation of the RPE65 gene, in fact, a biallelic mutation, which means that it affects both copies of the gene. And that mutation will manifest as either retinitis pigmentosa or Leber congenital amaurosis. So if there are 1 in 3,500 individuals affected by retinitis pigmentosa, when it comes to this specific genetic mutation, we're talking about in North America, individuals that total in the thousands, not the tens of thousands. So very, very small patient group. However, this gene therapy, Luxturna, has been approved and it is effective. The incredible thing about it is that it doesn't just halt the loss of vision, so it doesn't just put an end to your progressive vision loss. It actually restores a certain degree or a certain amount of sight as well.
Wow.
So we're talking about a legitimate cure for blindness. We just had to add the caveat that it's a very specific form of blindness. And that's the way that we foresee this unfolding. We're not going to develop a single cure for blindness because blindness is a kind of catch-all term.
Right.
We're really hoping to develop several cures or a basket of different treatments that will address all of these different forms of vision loss and blindness. But it's really important to start the conversation by talking about Luxturna because now we have a proof of concept. This company, Spark Therapeutics, developed a gene therapy in the traditional sense, and I'll get to what a traditional form of gene therapy is in a second, but developed this traditional gene therapy that does actually work and was able to make its way through the various policy hurdles that are in place in the United States to be put on the market. So I say traditional gene therapy because what Luxturna does is replaces the mutated copy of RPE65 with a functioning copy of the gene. And that's kind of the, excuse me, that's the dream of gene therapy. The original dream of gene therapy was to inject either through an actual injection or intravenously a functioning copy of a gene to replace a mutated copy. And now, as a result of Luxturna, we know that works. And if it works for RPE65, it's possible that it can work for other genetic mutations and other diseases as well.
So you really see this is the kind of thing that's going to accelerate, probably exponentially, I imagine, over the next little while, with people applying this technique to different conditions?
Absolutely, yeah. I think that this is the starting point. The one thing worth noting, though, is that the science, I think, will progress if it is supported appropriately. And that's always a challenge that we're facing because it doesn't just rely on scientists and their teams in labs doing the work that we know they're doing. It's dependent on support from government and various other stakeholders. It's dependent on where the market is for treatments at any given point in time. Just to provide you with an example, Luxturna currently costs in the United States $850,000. So that's a real policy challenge, right? Especially in Canada, where we have a public healthcare system. How do we take something that is that expensive and incorporate it into a public healthcare system where we can make it available to as many patients as possible?
Right.
So, yeah, when we're looking at the future of gene therapy, that's something that we really have to consider. I really believe in the science. I think that it's taking us there. But one thing that we're looking at, the Foundation Fighting Blindness as an organization, is ways that we can ensure that this treatment isn't just going to be available for the wealthy, but it's going to be available for anyone who is affected by the relevant disease.
And is that just a one-time treatment, or is there a chance the body will reject that gene?
We won't know about the body rejecting the gene, of course, until down the road when we see how patients respond. It's required in both America and in Canada and most other countries that in order for treatment to make its way to market, it does have to go through rigorous clinical testing. So it has been tested in human beings, and the results were positive enough for the FDA to say yes, this can actually be turned into a treatment. So certain scientists and certain policymakers feel optimistic, and yeah, it is at this point in time, at least, it is a single shot, so to speak, treatment. So you only have to receive it once, and you only have to pay for it once. And the idea is that it restores your sight to the degree that that's possible, and it doesn't go away. Now, it's entirely possible that down the road you could be treated by Luxturna and you could develop some other complication. It doesn't mean that you're not going to potentially get glaucoma, for example. But,
right.
Yeah, the idea is that you receive the treatment once.
That would totally suck, spending $850,000 to get your blindness cured, only to go blind from something else.
Well, it can happen. Yeah.
Okay, so gene therapy. So what other types of treatments are we dealing with these days? I guess there's drug treatments. Any advancements on the drug treatment side for RP?
Absolutely, there are really promising developments on in the space of pharmaceuticals. I'll just provide you with one example, and it's a relevant one because there was a big development for the Foundation Fighting Blindness in 2018. But one of the ophthalmologists that we're currently funding, Dr. Philippe Monnier, who is a scientist at the Krembil Research Institute in Toronto, he is the inaugural recipient of our Restore Vision 2020 Award, which is designed to accelerate those projects that are on the cusp of going into clinical trials, and in fact to help them make their way into clinical trials. And his work is focused on retinitis pigmentosa, but also age-related macular degeneration and glaucoma. So it has it has a lot of potential when it comes to quite a few diseases and a number of patients who could potentially be impacted by this treatment if it makes its way to the market. And the big discovery in Dr. Monnier's lab is that in those individuals who are affected by retinitis pigmentosa, there is an abundance of a protein called neogenin. So what he and his team are working on developing is a specific molecule which would take the form of a drug down the road. Again, if this makes its way through clinical trials and through policy frameworks, it would be a molecule taking the form of a drug that would be designed to block that abundance of neogenin. And the hope is that if we do that, if we suppress or block neogenin, we could potentially reverse the degenerative effects of retinitis pigmentosa and do similar things for AMD and glaucoma as well. So that's quite promising. We're really excited about the work that Dr. Monnier and his team are advancing, and we're really excited to be supporting that work as it continues in the lab and hopefully as it makes its way into the clinical trial stages. I should mention, and I mentioned the name of the initiative that's supporting Dr. Monnier's work. I should mention that initiative, Restore Vision 2020, is made possible by Donna Green, her mother, Goldie Feldman, and an anonymous donor. So it's a really good example of the incredible things that can happen when you have a community of individuals who are affected by vision loss and who are really motivated to make a tangible difference for their own loved ones, but also for Canadians in general.
Neogenin sounds familiar to me, and maybe it's because I heard it previously at one of the other speeches. But isn't it implicated in other degenerative issues as well?
It is. I'm mostly familiar with the work that he's doing as it relates to retinitis pigmentosa, and I haven't been able to read much at this point about how his approach is going to differ or how it's going to be the same as it relates to AMD and glaucoma. So I don't know whether those other diseases, the non-inherited diseases, AMD and glaucoma, also are linked to an overabundance of neogenin. I don't know whether that's the case or not. My suspicion is that is in fact the case.
So let's see. What we've talked about gene therapy. We've talked about drugs.
Stem cells.
Stem cells, for sure, yeah. Maybe I will circle back around to neogenin just for a second because something occurred to me. But Dr. Monnier's approach to neogenin is obviously exciting because we are focused on advancing that research that is going to make its way eventually into clinical trials. But it's worth noting that studying neogenin is valuable as an approach to foundational science. So yes, Dr. Monier's work on neogenin could lead to the emergence of a treatment down the road that will affect the lives of patients. But his exploration of neogenin also tells us something about the human eye. And I think that sometimes that in the all the excitement around emerging treatments and considering everything that we've said about Luxturna and the fact that we are kind of on the cusp of cures for blindness right now, what gets lost is the fact that foundational research is still essential. And if we forget about that, then what we're going to do is kind of curtail down the road, potentially significantly down the road, curtail the development of new treatments that would otherwise be available to us if we continue to support what some scientists call basic science, what others call foundational research. But basically that work that kind of tells us more about the human eye, how the eye communicates to the brain, how the retina functions, how its different cells and molecules communicate with themselves and with the brain. This is all essential, and all the work that's being done in the treatment space right now is entirely dependent on decades of foundational research. So that's another way of thinking about Dr. Philippe Monnier and his team, is that yes, the Foundation Fighting Blindness is supporting that work as it transitions into later stages that we hope will lead to clinical trials and eventually treatments, but also neogenin tells us something about the human eye and how it functions, and that's absolutely essential.
Cool.
So that's me circling back around to neogenin. As far as stem cells are concerned, I'm really glad that you brought that up, because in the excitement surrounding Luxturna, one mistake that we could make is to forget about stem cells. And that would be an enormous mistake, because there is so much potential in stem cell therapy. In fact, one thing that we've been talking about it for a couple of years now at the Foundation Fighting Blindness, but we've been talking about it more so over the course of 2018 and this last month, is something that we think of as combination therapies. So yes, there are approaches that exist purely as stem cell therapies or gene therapies, or pharmaceutical advancements or artificial vision. But one thing that holds a lot of potential is this idea of combining those different approaches. And that's something that Dr. Andras Naj, an FFB-funded scientist who is at the Lunenfeld-Tenenbaum Research Institute in Toronto, that's something that he's doing. In fact, he's combining stem cells and gene therapy to develop a treatment for age-related macular degeneration. And what he's doing very specifically is finding ways to genetically engineer stem cells before they are transplanted into the eye. And what he would like to do, since he's working on AMD, he would like to genetically program stem cells to release a molecule called anti-VEGF that would have a real impact on individuals who are living with AMD. So just to backtrack for 1 second, VEGF is VEGF. It stands for vascular endothelial growth factor. And it's something that's naturally produced by the human body in relation to the development of blood vessels. In fact, our body is capable of producing new blood vessels as a result of this protein, VEGF, when we lose older blood vessels. But in those individuals who are living with age-related macular degeneration, and also for individuals living with diabetic macular edema, which is the worst form of diabetic retinopathy, in those patients, VEGF goes out of control and starts to overcompensate for lost blood vessels. And in the advanced stages of AMD and in diabetic macular edema, what that leads to is an abundance of blood vessels that have developed incorrectly, and they swell and they hemorrhage and they actually leak blood into the eye. That's why we distinguish between dry AMD, which is the early stages of AMD, and wet AMD, which is the much more severe form that is more closely tied to severe vision loss. So patients with AMD and with diabetic macular edema for years now have had a treatment available to them, which is anti-VEGF. It is a molecule that suppresses the out of control nature of their existing VEGF production. The problem with this treatment, or it's not really a problem, but one of the characteristics of this treatment is that it can be quite invasive. You have to go in for monthly injections into your eye. And you can imagine that that's probably not a very pleasant thing to experience it. Having to go into the clinic every single month to get a needle in your eye.
I don't have to imagine it. I watched my dad go through it.
Oh, okay, there you go. Yeah. So this is something that Dr. Naj and his team are working on, is actually engineering that stem cell so that it can be transplanted into the retina, and it can time release this molecule, anti-VEGF, on its own. So rather than going in every single month, you could go in once and have this engineered stem cell injected into your eye, and then the stem cell can kind of go off and do work on its own. We don't know what this will look like. It's still in the research or lab phase right now. But ideally it would just be that single injection of the stem cell into your eye, or, maybe it would be annual injections or something along those lines. But our hope is that, maybe someday this treatment could emerge and it could replace the existing standard of care for patients with AMD and diabetic macular edema. So that's a really good example of a project that is finding ways to combine the approaches of both gene therapy and stem cell therapy.
Cool.
Yeah. One thing that is worth noting when it comes to both this project and stem cells in general is that stem cells are amazing. We all know this. Stem cells are in the news all the time. That's going to be the case going forward, certainly. But part of what makes stem cells amazing is that they are able to self-replicate, and they're able to turn into different types of cells. That's why they're useful. They have this kind of malleable and amorphous quality. But they share that characteristic with cancer cells. That's what makes cancer so devastating, is that it can self-replicate and it can turn into different kinds of cells that you find in all over the human body. That's why you can have brain cancer or lung cancer or many different forms of cancer. So we know that this is an issue, and one of the potential issues with stem cell therapy is that we could put a stem cell, even an engineered stem cell, into the human eye, and there could be unforeseen consequences. So scientists are doing amazing work when it comes to stem cells in vitro, in a test tube or in a vial, and they're able to do incredible things. But one of the real hurdles right now is, what happens when we take those stem cells that you've done miraculous things with in vitro and we place them in vivo in a body or in a live biological environment. There could be cascading consequences.
Right.
So that's something that researchers are working through right now. But one thing that Dr. Naj and his team are very aware of is this potential issue, and they're getting out ahead of it with this system that they're working on that they call the Safe Cell System. In fact, they recently published information on the Safe Cell System in Nature, the scientific journal Nature. And what Safe Cell essentially is a remote-controlled kill switch for engineered stem cells. So the idea is that the Safe Cell System will allow researchers to track what is happening with these bioengineered stem cells that have been injected into the human eye or even into the human body, be able to track what's happening with those stem cells and monitor progress. And if something goes wrong, flip the switch, so to speak. That's a metaphor, because I'm sure it would be something other than an actual switch. But basically flip the switch so that the stem cells are shut off, and whatever problem is taking place is put to an end.
Yeah, last thing you need is stem cells turning to the dark side.
See, and
that's right. Yeah, absolutely.
See, that's smart. That's smart. Like, these people who are working on AI, take note.
That's right. We need a kill switch.
Kill switches are a good thing.
Well, I was thinking, if you combine this approach and you can do a gene replacement, could we have an off switch for politicians?
I'm going to call him after our conversation to scale up the safe cell system so that it can be applied to any number of things, including politicians.
Can you talk to us a little bit about the education work that you guys do at the foundation as well? Because I'm sure that's part of the fight too, is taking all of these advances and educating the public in general and letting them know what you guys are up to. What kind of things do you do in terms of that?
Yeah, I'm really glad you brought that up, because that's so incredibly important. I mean, one thing that we're constantly facing is the fact that science too often exists in this kind of isolated bubble, where scientists and other researchers and sometimes policymakers are speaking a language of their own, and the patients who are actually affected most profoundly by the products of science, don't really have any awareness of what's going on. So we're always combating that, and one of the ways that we do that is through an in-person educational series that we've had for many years now, called Vision Quest. And Vision Quest takes many forms, but it's always a combination of scientists and staff here at the Foundation Fighting Blindness, and policymakers and industry representatives and patients being in the same physical space and talking about work that is ongoing, and treatments that are currently available, and resources that are available for patients, to try to connect those dots, to try to break down those unfortunate barriers between science and the patients that are affected by science. So we hold Vision Quests every single year. We hold it at multiple sites across the country. In fact, we're going to Winnipeg next month. Then we'll be in Vancouver in April. We'll be holding an event in May in Toronto. And we'll be going to Halifax in September, and again in Toronto in October. And then hopefully we'll be going to Calgary in October as well. Take that with a grain of salt, because that's kind of our initial planning. We're kind of releasing concrete details. We'll be releasing concrete details on our website in the near future. That website is ffb.ca. But yeah, that's our educational series, where we often have researchers and scientists that we're funding up in front of patients talking about the work that we're doing. And we also do our best to give patients some sense of what resources are currently available to them. Because that's one thing that happens inevitably, both in Canada and elsewhere, is that you get diagnosed with a disease. You can take retinitis pigmentosa as an example. It sounds quite scary, and the news is really scary. You're essentially told by your ophthalmologist that you have an inherited form of degenerative vision loss, and it's going to manifest as a kind of increasingly more extreme form of tunnel vision, and that's going to lead, whether it be 5 years, 10 years, or 20 years, to you being either blind or very close to blind. So that's scary, and then the patient is kind of left on their own to go out into the world and kind of figure out what that means. So at Vision Quest, we try to provide individuals with some information and with some support, and yeah, that's one of the key things that we do at Vision Quest.
Now, one of the things I learned at the last Vision Quest I was at is that you guys actually actively track a lot of research and can also provide linkages for your not your patients, your clients, to different research opportunities. How does somebody get linked in with you guys and get connected?
Yeah, so there are a number of ways to do that. We try to be as open as possible to communications from patients. So that could be giving us a call here at the office. We do our best to pick up the phone every single time we hear it and provide help for individuals on the phone. And we also have resources that are online. So One thing that we've had available for a number of years now is our patient registry, which is essentially a database of Canadians who are affected by inherited retinal diseases. So if you are diagnosed with an inherited retinal disease, you can go online and add your name and your information to our patient registry, and we will send you contact information to reach out to what we call a registry center. We have 4 sites across Canada, and that will start a conversation with a medical professional who will ask you questions about your genetic history and your diagnosis, and basically put you on a list so that you can be available for any clinical trials that are relevant for you and your disease. So if you're someone who's diagnosed with an inherited retinal disease, you're interested in being part of a clinical trial, the patient registry is something that's available for you as a way of being put in a queue to access those trials that are relevant for you. Another thing that we do have on our website is something that we launched in 2018, actually. It's called Vision Care Pathways, and it's essentially our primary resource available to individuals affected by vision loss. You just go to our website, you see, I think it's right now, it's a tab on the top of the site called Eye Diseases and Pathways. You click on that, you'll see a pull-down menu of a number of different eye diseases. We've covered the main ones that we've been involved in advancing research on. You click on the disease that you or your loved one is affected by, and we provide quite a bit of information. So we provide an overview that kind of tells you about the disease. We give you information on what the disease's pathology is, how it relates to the genotype, and we also give you a link to the patient registry, as well as a link that will take you to a site called clinicaltrials.org, and that's the site of, that lists clinical trials that are currently being offered internationally.
Does that site provide any kind of rating of those things, of those different trials? Like some of them can be pretty sketchy, I understand.
Yeah, I'm really glad that you brought that up. So clinicaltrials.org is run by the National Institutes of Health, American organization, but the NIH is very clear up front about the fact that they don't vet any of the clinical trials that posted to the site. So right now there's this process that's available for basically anyone who's involved in running a clinical trial to go ahead and upload relevant information. So you're correct. What that has led to is this situation where phony and in some cases dangerous clinical trials that really don't even deserve to be called clinical trials are being posted to clinicaltrials.org. So on Vision Care Pathways, that resource on our site, we have kind of outlined that in as much detail as we can, and provided a kind of disclaimer telling patients that if you're going to use this tool that we've provided, that will take you to clinicaltrials.org and pre-populate your disease and provide you with a list of clinical trials, you still have to consult your ophthalmologist anytime you're considering a clinical trial, because we just don't know what's out there. Unfortunately, the clinical trial landscape has become a kind of cottage industry, and there are some really problematic things happening. I believe that a couple of women in the United States were blinded last year as a result of becoming involved in a clinical trial that wasn't really based on sound science at all. Now, there are a few things that you can do to identify illegitimate clinical trials in the space of vision science. One of the nice things about the human eye is that we have 2 of them, and what that means is that you have a built-in test. So anytime someone is saying that they're going to perform treatment on you in both eyes, that's a red flag, because no one should ever be doing work on both eyes. There's no point in doing that.
Right.
And that just means that if there are any issues, then that could be more pronounced because it's affecting 2 eyes instead of 1. So that's a real red flag. Another one is anytime someone is asking you for money. If you're involved in a clinical trial, you are essentially volunteering yourself to the scientific process. You could even be offered a placebo, and it could have no effect on you whatsoever. If you do actually get the treatment, or sorry, I should say intervention, it's not a treatment until it makes it to market. But if you are offered the intervention, it could have no impact whatsoever. It could be ineffective. So what all of this means is that you should never be paying for this sort of thing. If the clinical trial is legitimate, it won't be asking you for money. So that's another way of identifying a phony trial. And we always tell patients and supporters that you should feel free to reach out to us if you ever have questions about clinical trial. At the very least, we should be able to point you in the direction of someone who can give you some concrete answers.
Where can people find Foundation Fighting Blindness online if they are interested in any of this?
Yeah, so it's ffb.ca, simple as that. And that'll give you all the resources that I've mentioned, as well as contact information. And we are open to being contacted in any way. So like I said before, that could be a phone call, that could be an email. It could be taking things into your own hands and signing up for the patient registry on your own, whatever makes sense for the individuals who is seeking us out.
Listen, Chad, we want to thank you so much for taking some time out of your day and talking with us. It's fascinating hearing about some of the progress that you guys are making. We'd love to have you on again at a future point and talk more about more of them.
Yeah, I'd love to be on. Thanks a lot for having me. This is one of the things that is a joy to do, is actually talk about science that we're helping advance, and talking about the way that it could affect the lives of patients. So really glad to be on and happy to talk in the future.
Sounds fabulous.
Okay, take care.
All right, bye-bye.
Wow, okay, that was pretty fascinating. A lot of terms, I have no idea what they mean, but
yeah, I mean, if you're somebody living with one of those conditions, you'd know a lot of the terminology, I imagine.
I'm sure.
But yeah, that the foundation is just doing some really cool work and tied into some amazing research. I love what they do, and I just love hearing about it, because there's so many amazing things going on. Yeah.
But it does bring up an interesting quandary. Like once we do develop treatments for some of these eye diseases, like especially what struck me is especially macular degeneration, because it's such a common eye disease that affects so many people. If they do develop a treatment for that, and it is, say, for example, $850,000, how are we going to manage that? Like, how are we going to make that available to the amount of people that are actually suffering from macular degeneration without bankrupting the country?
Yeah, I mean, it's astounding when you hear numbers like that for a single treatment.
Right.
And you wonder, ethically how they justify that. But then we don't know how much money was spent researching that cure. We don't know how many people necessarily are, able to use that cure.
Right.
But it is a cure. It's not a treatment regime.
Right.
We've got lots of drugs that are approved in Canada that cost, tens to hundreds of $1,000s per year as an ongoing maintenance schedule that somebody's going to be on for the rest of their natural life unless something else comes along. So
that's true.
That's true. If the government can negotiate drug prices with a company like that and bring it down to, a reasonable level, there's some real potential. But that one cure, that affects, I believe he said, 1 in 3,500 Canadians.
Yeah.
That's a fair number of Canadians, and it's a disease that typically is diagnosed when they're fairly young. So if you're looking at, $800,000 across the span of a person's life,
true.
It has, we already know that blind people are typically underemployed. They find it more difficult to get employment. They have a lot less opportunities when it comes to certain aspects of life. Is it worthwhile for, somebody who's 10 years old to get that treatment? Damn straight it is.
Right. Sure.
If you're 90, maybe not so much.
Yeah. Right. Sure. Yeah, it's a good point. That's a really good point. Yeah. So fascinating stuff. And, and it makes you just wonder, like every year, it sounds like, they're breaking through in something. And I get the feeling like, again, I'm no scientist, At least not this week. By next week, I may be a scientist as well as journalist, comedian, and whatever the other one was.
Yeah.
But you know, it seems to me that once they've cracked that code and they're able to cure one eye disease through gene therapy or through stem cell research, it makes it that much easier for the next one.
Yes.
And then the next one, and then the next one. And it's like a domino effect. And soon all these eye diseases will be falling. And so that's the really exciting part of it, is that, you know, we could be at the beginning here of some real progress.
Well, genetic therapy, I mean, there's so many genetic conditions out there, unique genetic conditions that people have. The idea that it's like, oh, you've got this. Oh, here. There you go.
Replace that gene, put in a kill switch. And
Yeah. You know, there you are. You're cured. You know, it's just crazy.
Mm-hmm.
You know?
Well, think about cancer treatments, right? You know, I'm sure there's cross research being done. You know, if they can do gene therapy on an eye, you know, gene therapy to replace cancer cells, or put kill switches.
Yeah.
You know,
Yeah.
using stem cells for cancer treatment.
Mm-hmm.
You know, if they're self-regenerating, you know, are we that far off from being able to cure some types of cancer?
Yeah.
Well, that's our next guess, eh? Call the BC Cancer Foundation. Let's find out where they're at. Actually, I have a friend who works there.
Yeah. Yeah, it's such a broad field, you know, stem cell and gene therapy. You know, it's so kind of cross-platform, right? It can be applied to anything.
Oh, and just think, 10 years ago they were fighting over stem cell research.
Mm-hmm.
Remember that?
Mm-hmm.
You know, it's just, and you probably put it back 10 years.
Oh,
with all that fighting.
Undoubtedly, but they didn't want. You know, there were ethical considerations around using fetal stem cells. Now they can take any cell, put it in a chemical bath, and turn it into a stem cell.
Oh, okay.
So there's, you know, the science progressed in that time to a point where the ethical concerns were not there anymore.
That's what happened. See, I didn't know.
Yep.
I didn't realize that's what happened. I thought they just figured it out. But anything else to say about that, fellas? Do you feel like you're smarter?
Oh yeah, absolutely. Yeah, I think I'm a doctor now.
That's right. Hey Ryan.
Yeah.
Where can people find us?
atbanter.com.
They can also drop us an email if they so desire, atbanterpodcast@gmail.com.
And if they're really inspired, they can find us online on them social networks. There's Facebook, there's Twitter, and there's Instagram.
You know, we might have to actually switch this up so you're not talking about Facebook or Twitter or Instagram and being a hypocrite, given that you've given all of those up.
I have.
Cold turkey.
Yeah.
So
No, it's good for him. It's good for him to relive that.
Is it?
Yeah, I think so.
You sure we're not maybe triggering him?
Well, I tell you,
his fingers are twitching.
He's not. Well, he's missing it to a certain extent.
Yeah, I totally am. I really am. I'm missing the connection that I had with my family through Facebook. I'm missing being able to shout at Trump on Twitter. Mm-hmm. You know, but I've never been mentally healthier.
There you go. So you would recommend it to everybody?
Yeah.
Well, that'll be
so. Social media, as far as I'm concerned, social media is poison. It's poison for the mind. It's just. It's such a
except our social media feeds, everybody. That's what he meant.
Well, it just
it can be so.
No, I know.
It just allows people to be anonymous dicks all the time, and you know, you get into debates online, and they typically devolve into, you know, pissing contests and
personal attacks.
Yeah, it's just not a very nice place to play.
I'm telling you, I think 2-3 years from now, I think it's going to be it's going to look very different, because I think there is the pushback against Facebook in particular is really growing. They did not have a good 2018, and I don't think it's going to shape up. They're going to have a much better 2019. Look at the study that.
Well, the demographics have changed.
But you know, just look at the study that came out. What was it, last week? That talked about specifically fake news and the fact that, what was it? People over 65 were 75% more likely to pass on fake news articles.
The most likely people to pass on fake news articles are senior citizens and conservatives.
Right. Yes. So, it's a real growing problem. And Ryan's also absolutely right, too, is that the demographics have completely changed. People under the age of, I would say 30 don't really use Facebook all that often.
No. Abby and her crew are like Instagram and Snapchat.
Yep.
Mm-hmm.
Yeah.
Instagram's the new thing. Yeah. Well, it's not so new, but everybody seems to be moving over to that platform.
Isn't that owned by Facebook as well?
Yeah.
I think so. Yeah. They probably own it all, but I don't know. So it's going to be interesting to see what happens in the next few years. But I suspect that their reign at the top is beginning to.
Let's have a bagging on social media episode.
Oh, I was actually thinking of getting the Canadian Mental Health Association to talk about social media and the mental aspects of its effects.
No, that's a great idea.
Except our feeds, everybody. Our feeds are wholesome. There's no fake news.
We don't post anything. That's why they're wholesome.
Shut up. I post stuff all the time. You post stuff. It's great. It's lovely.
It's great.
So
check it out.
So really, what you guys should think about our social media feed, it's just a conduit to Rob.
Pretty much.
That's right. Pictures of my cat. Okay, is that it? Or did we cover everything?
I think we covered
did.
everything.
Okay, everybody. Thanks.
Bleep, bleep. That's all, folks.
Google Glasses.
Google Glasses. Goo
goo.
I'm going to be like that old Polish woman.
How do you use your Google Home if you can't say Google?
Sometimes it takes me a couple times. I don't know why I can't. I think I need to go to speech therapy. I should have bought a Alexa.
I need to get you a communication aid.
Shut up, Alexa. Not you. Okay, everybody, that's going to about do it for us this week. We will see everybody next week.
This podcast has been brought to you by Canadian Assistive Technology, providing low vision and blindness solutions across Canada. Find us online at www.canasstech.com. That's CANASSTECH.com. Or call us toll free at 1-844-795-8324. For all your assistive technology servicing needs, call Chaos Technical Services at 778-847-6840 or find them online at chaostechnicalservices.com. Music provided by bensound.com.
Whoa, look at that. Master of the one take.